Hello everybody, my name is Elvar, and today I'm gonna talk a little bit about STM32 microcontrollers GPIO interrupts. And for that, let's make a new project. I've got my discovery port F4 here. Let's start the project, and as I've done it before, just clean the pin out, set up the clock, set it on 160, and yeah, I'm gonna change this as well. So what I want to do this time is I want to show you how to handle the interrupts, and I'm gonna take some random boards. I like to take the PD D board pins for just a random GPU action because they don't have much of the other functionality available. As you see, the other pins have much more possibilities. So I'm gonna just take the 3 and 4 for example, and what I'm gonna do here is that I'm gonna set one of the pin GPIO XE3, and the other one I'm gonna just set the GPIO output. So, and yeah, let's give the project a name, GPIO interrupt, and gonna use again Kyle this time, and gonna generate the okay. I think we are now set. Don't need anything else at the moment, or maybe maybe I want to print something out, so I'm gonna set the UART2 as well. So let's generate the code. And let's open the project. So what I'm gonna do now is that I'm gonna connect these ports on my board. The PD3 and 4 are here. So the thing here is that I want to trigger an interrupt with one board, trigger the other board's interrupt. So let's go to the main function here, and for beginning I'm gonna go and add some lines of code to use the printf function if I want. Yes, let's put it here, and let's include standard input output header as well. So now what I'm gonna do next is I'm gonna go to this file here, STM32 It's basically, you can see all the interrupts here what you have enabled. There are some handlers here, and as you can see right now, there is no interrupt handler for GPU because I forget to activate it. To do that, you need to go back to go to system view and GPU, and what I'm gonna do here, I'm gonna activate under NVHC I can activate the line 3 interrupt, and yeah, that's basically all. Now I'm gonna generate the code, and when I go back here I can actually see that the handler is now here, And you could write something here. For example, let's write here printf interrupt and why is it giving a warning? I think I have to include. Let's see if it's building right now. Okay, I got one warning. Let's try again. Okay, now it's gone. Okay, I needed to include this as well. And what I'm gonna do now, interrupt is triggered, then the signal changes from lower signal to higher signal. And right now, my let's print out the PD free pin value. For that, we can use printf. Okay. And for that we have a function GPIO read pin, and it's a GPIO T and GPIO pin free. Sorry. So this should now print out if the pin is high or low, and I have each term here, and if I press the reset button on my controller, we can see that this is low. And yeah, maybe it's just floating around, so we can actually, let's put a little delay here, like for 100, and let's do the same thing here. And when you look on each term, we can see that it's constantly 0. What happens? Okay, let's stop from here. Let's take this down from here, and what I want to do here is now, after that, I print out the pin value. I'm gonna change the GPIO PD4 pin to high. That was our output pin we set in the cube, and let's print out again the pin free value should be high as well now, and we should see the interrupt text here as well when we do that. So let's open the H term. Let's clear everything, and I'm gonna reset the board now. And as you can see, exactly that happened, that the interrupt is triggered. And to make sure that the interrupt is only triggered when the signal goes from lower to higher, at the moment we can reset the pin, and after that we shouldn't see the text interrupt. So, and when I press it, as you can see, I only saw interrupt once. So this is one way where you can type your things you want to do, but it's not the right way to do. Or maybe it is, I don't know, but I'm not used to it. I'm used to looking at some other functions, and the functions we need to generate is or overwrite is a GPIO x1 callback function. So what we want to do here is this is, as you can see, this is a weak function, and weak functions can be overwritten with your own code. So basically what you want to do is we're going to copy this text here. We're going to go to the GPIO.c file in our place, because you should do this here, and I'm going to copy it here. And now I can write my code, what I want to do when the interrupt is triggered. So I'm gonna put this one here, and here we can actually do it just like that, or we can choose what we do with different pins. And right now what I'm gonna do here is I'm gonna include the study.a, yeah, because of a printf function, and same things will happen now. If you look at the h term, okay, let's clear it, it's better to understand. So exactly the same thing happened. We got the interrupt text, and yeah, let's dive. Usually you should check the bin here if it's a bin free, to make sure we are ending the right one. And let's put else. Let's print out else. We shouldn't get there as far as I understand, but just in case. And let's clear it. Sorry, let's just clear it and reset, and we safely get there we want. And if I want to, like, let's say, get the pin 4 interrupt, then we should get the else text. Yeah, so this is called the HAL GPIO EXTI callback function, and this is where you should handle your GPIO interrupts. So okay, let's try something else. Let's go back to the cube and to the pinout. Sorry. And what happens, for example, when I take some other pin freeze as well to the interrupt? Let's say take the PV3 as a X1 as well. As you can see, what happens here is that you can only choose one of them to be the interrupt pin. So yeah, you cannot choose both of them. So you cannot. You won't have any problems here if you compare with GPIO pin 3, when it will be the pin 3 you're selected for interrupt. And as you can see, there are like 16 different possibilities to do the interrupt, so there should be enough pins for you. And yeah, I'm gonna show you one more thing. I want to generate some PWM signal and count the interrupts and print out like every 100 milliseconds how many interrupts we have had. And for that, I'm gonna use the let's see. Okay, let's open it again. I think this is the 11th one is good for us, and gonna choose 79 here and 10,000 here. We should make it 1 million. I'm gonna make 1 millisecond. I'm gonna choose not 10,000 but 1,000. Yeah, we should make the trigger every 1 millisecond, and there should be, actually let's do every it should go up every 1. Yeah, it's okay. Let's leave it like that. The pin for that will be the BB9. I'm gonna generate the code. Okay, sometimes when Kyle is open, it will froze here, but if you go to the main function, I think we have, no we haven't. Okay, so I'm gonna close Kyle, I'm gonna kill the STM cube. I'm gonna reopen the STM cube, and I'm gonna open the project again and generate the code. And open the now I can see that I have the team here as well. And what we have learned from a previous video, that we can this, yeah, we can activate the timer by hell sorry, I'll time base start 11, and we need to activate the PVM generation as well. PVM start for HTM11 team channel 1, and we're gonna set the compare register as well. I'm going to just set it to alpha of what we have chosen, so it will should go up now every 1 millisecond. So and I'm gonna connect my PB9 pin to the PD3 now. So let's do that. Where is the PB9? Oh, where is it? Okay, I found it. Gonna connect it. You should actually, yeah. So now we can trigger an interrupt PWM signal, and let's go back to the code. Gonna go back to the interrupt function I wrote here, and what I'm gonna do, I'm gonna make a global variable here. Let's call it G counter. It will count every time the value then interrupt is triggered. Should be free, and I'm not gonna print out this. I'm gonna just counter plus plus here, and I'm gonna go to the header file as well here. I'm gonna add the same variable here as well. I'm gonna make it external, so I can import it to the main as well. So, and I'm gonna put this one over the private variables. So, what I want to do here is, after every 100 millisecond, I'm gonna print. I'm gonna do it not every 100. I'm gonna do it 99, because I think the printf will also take 1 millisecond of time. Let's see. And counter. And this is a C counter. So it should now print out the value of the counter after 100 milliseconds. It should Okay, and let's see what's happening. As you can see, we're gonna disconnect from here so we can see what's happening. It's actually pretty nice. I can even make it, yeah, it's like plus 101 every 99 milliseconds. I think it's just because of the printing out function and everything. If I correct it a little bit, and I'm gonna reset it, yeah, now it's like going up 100 after every 100 milliseconds. So yeah, so you can see what is happening. One interrupt every millisecond, and which is how we can count the for example, if you're using your PWM signal to control the stepper motor, you can count how many steps you have done. But keep in mind that it will count if you are not, if you are stopping your stepper motor. You should make some if statements here. For example, don't count then let's say if GPIO read pin for is low, only then count. Okay, we are missing here one practice. Okay, now so it will count only then this pin is low. And if you're gonna go, let's go back to main. Let's see what we did. Yeah, so the pin is set low, so it shouldn't count anything. And when I load the code and go back to HTerm, we can see actually oh, it only counts when it's low. Yeah, let's take this out here. It should no, it shouldn't be. Should stay 0 now. Let's see. Yeah, as you can see, the pin is high, and because of that, they won't count anything. And that's how you can like have a little conditions here on interrupts. But you should have as few code here as possible, because yeah, sometimes when your next interrupt is coming and you haven't handled everything here, so it's very bad. So keep it simple, and I hope this video will help you understand how to use interrupts to do some stuff in your code. Anyway, thank you for watching, and bye bye.